I'm Saifur Rahman from Dartmouth College. Now I'll be talking about 3D printed liquid metal research coil. So picture a world where electronic system is stretching and bending like a rubber band. I told that to an AI tool, and it spits out this image on the left. They look pretty futuristic and cool, but we're not quite there yet. So one of the main things holding us back is the stretchable passive devices. And capacitors can be scaled well with geometry and can be put on a flexible substrate, but inductors, they require different kind of scaling to get that to that similar performance. And they're rigid and bulky. So I'm working with gallium-based liquid metal to make coils out of those. And specifically, I'm looking into the high-frequency electromagnetics of it. And if I can make those inductors more efficient by looking into the high-frequency electromagnetics of it, I can get those cool applications from soft actuator to smart textile, etc. So the problem is at high frequencies, current does not use the whole cross-section of the conductor, which is because it exhibits eddy current losses, and it is coming from the proximity effect from the nearby traces. To mitigate this issue, people have been using Litzer, and Litzer basically divides the solid wire into tiny strands, which are insulated and twisted with similar diameter, which gives you more surface area. And inherently, you will have less current crowding on the edges and lower AC resistance. With lower AC resistance from the top equation on the right, you will have higher quality factor. And quality factor basically means how good is your coil on dissipating resistive losses. So care about quality factor because this gives you higher wireless power transmission efficiency from the bottom equation. And I'll be using this kind of technology for liquid metal coil and at a certain frequency such as NFC frequency. So I choose 3D printing, which gives me immense flexibility on design, and also gives it can be the suboptimal packaging that comes from traditional microfabrication of PCB. I have been using microstereolithography, which is a high resolution printer, gives you tens of micron in resolution, and make those coil in a shape that follows the research structure. So I would have control coil, which is solid wire coil, and the new design, optimal design, which is the research coil. And with that kind of design, I forgot to say that you obviously inject liquid metal inside those tiny channels, and you came up with this hollow disk structure. And we did take some X-ray CT images, and to our surprise, it gives us 90 to 92% filling of the liquid metal. And this kind of design gives you better quality factor, almost 2x improvement, and it is superior to the best reported liquid metal injector so far. And I tried out wireless power transmission with this kind of design, and you can see from the and we all got like 20% improvement on the efficiency. From the videos, you can see the LED connected to the solid coil is less brighter and smaller, has smaller wireless power transmission range, and this coil has, on the other hand, a brighter LED and larger wireless power transmission range. So now the question is, how do you increase the inductance density on similar geometry as you're talking about scaling rule? We show our ability on fabricating ferrite core-based inductor, not air core-based inductor anymore. Previously, we were getting 200 nanohenry with the previous structure, but if you want to get a higher inductance intensity, you can use the toroidal geometry and also put ring-shaped ferrite core inside one of those structure, and you have a very high inductance intensity. So this is the first time I've shown this. We laser cut those ferrite core into ring shape, stop the printing halfway, put that ring inside it, and then resume the printing again. And with that kind of technique, we got 5x boost on the inductance. It's only because toroid and synergistically the ferrite core gives you more inductance per area. So in conclusion, new design and fabrication method of stretchable liquid metal coils are presented, and high quality factor of 3D printed liquid metal coil gives you enhanced wireless power transmission, which is 20% more than the solid counterpart. And you have more flexibility to tune the interface intensity depending on the use case. Thank you.